Welcome back, my friends, viewers, followers. Today we're going to work on the carburetor from the old 1937 Briggs. Here's our intake tube, here's our carburetor. We're going to disassemble this carburetor and clean it in the sizzle tank. Okay, for starters, we're going to remove the choke assembly, which is a separate piece for some weird ass reason. I'm not judging. There it is. Off with her head. Now each joint is basically fitted like the foot joint of a brass instrument, or a like a flute, where every little piece is carefully honed and machined to fit together. It's a very simple carburetor. Look at how the body, this is the main part of the carburetor. This is the carburetor tube, the body, and the float assembly. It's very strangely built. Not like anything I've ever worked on before. Unfortunately, there are no parts available for this anymore. I cannot find any parts at all. So we are limited to what we have to work with here. We're going to have to make all of our own gaskets. I have some gasket material here. There it is. So we're going to have to, now I don't have anything this thin. The stuff I have is just a hair bit thicker, but that shouldn't be a problem. We're going to keep the old gaskets to use as templates. We're going to make sure we don't lose any pieces. So we're going to put all the hardware in here. I think I'm already missing a split washer. I don't have, yeah, I'm missing a split washer already. Look at our choke. Let me get some more light. Oh, I have all the light I can get here. But take a look at this. Let's put this light on here. There we go. This is crusty as hell. Let's see if we can get it any nicer. Very, very crudely made compared to anything made today. Or hell, even made in the 40s. This is the tiny, look at that throttle plate. Look at how tiny that throttle plate is. Have you not seen a smaller throttle plate in your life? It's just so crude. There's our Venturi. It's got a tiny little Venturi right in there. And your jet. There's your jet right there. Okay, what I don't understand is why there's a jet located on the side of the carburetor body. We're going to figure that out in a bit. So this is our mixture adjustment. And I'm going to have to take this out. Careful not to lose anything. We're going to be really careful here because there is a tiny little spring-loaded, yeah, here's our needle valve. Look at that little thing. The camera won't focus on it, it's too small. We'll clean that up with steel wool after we take it apart. I want to make sure that this right here, there is a spring-loaded detent that keeps this jet in position, prevents it from backing out. It's a very innovative, very elaborate way of building a carburetor, but you know. This is not a Tillotson carburetor. The Tillotson carburetors were on the later models. This is a Briggs and Stratton own product, I think. So we'll take the float chamber apart. Here's the top of the float chamber. It's got a shellacked cork float. That has me concerned because I believe ethanol will eat away at the shellac. So we're gonna have to, we might have to run this engine on True Fuel, which is a straight fuel. This carburetor bowl is disgusting. So how this float works is a little bit different from your modern day float. Well, it's not. It's the same concept, but it's much simplified. So it's got a tack in here. This is a weight. I believe these are weighed, or these are put into like a water tank, and they have to float to a certain level from the factory. And if they're too light, they put a tack in there. That's my theory. It's not fact, it's a theory. We're not going to clean this in the ultrasonics. I don't want to destroy it. We're just going to clean the valves, or the needle valve with some steel wool. So here's our float chamber. Now there's a passage that goes under. Yeah, we got to take this off. This is, I believe, the float drain, bowl drain. We'll take that off. That way the cleaning solution will get where it needs to go. So from the looks of it, the fuel is drawn possibly looks like, oh wow, okay, there it is. So the fuel is drawn into this tiny little port. I'm going to try to point this out. I use the needle valve. There's a tiny port right here, just sort of right up inside there. You can't really see it, but there's the port as the fuel is sucked up into here, into this port here, and it's drawn somehow. Kind of hard to tell. Why there's a jet though? Why there's a jet here, I don't understand. I'm gonna pull this out. I thought initially this was a, I don't know, a spare, or maybe a differently sized jet and they just store it in the carburetor body. But that's a passage. It goes, looks like it goes into another, yeah, okay, so it just goes into the adjacent screw hole. So that's really strange. No, because that port goes all the way, it's drilled all the way down into here. I don't know what it's for. If anybody knows, I'd love to hear from you. So, why don't we do this? Why don't we put all these parts into our ultrasonic bath for a little tubby time. I'm going to have to put a little more water in there. I think I undercut myself with water. Put all these parts in there, and we're just going to let them have a little hot tub time machine love fest. Hell, why don't we throw the screws in there too? And that thing. We'll just see what it does. Okay. What's this? A split washer? So far there's only 2 gaskets I need to make. It's going to be the float chamber gasket, which I'm not even sure what that would have looked like. And I'll put that in there. There's no point in putting the float in there for obvious reasons. I didn't think I had to explain that, but... Okay, so we're going to just kind of let it do its thing. We're going to probably put it in here for probably 20-30 minutes or so. See what happens. Okay. So the solution I'm using, it says not to use with aluminum because it will discolor it, but I'm not too concerned about that. In the meantime, we need to make a new gasket for the float chamber. So we're going to use some of this. This is gasoline resistant. It's tan fiber. I'm going to tell you a funny story. When I was a kid, my dad let me use our family lawnmower to make a few bucks, mowing neighbors' lawns and whatnot. So now we need to make a new gasket. So I need to use the back of this notepad. And I cut out a piece of this material. Alright, so we're going to draw out our gasket. Pen. one that works. Here. Okay. I was never much of an artist in school, but I could sure trace things. So my story is this. When I was a kid, I would use my parents' lawnmower, my dad's lawnmower, my dad's. My mom never used it, so it was my dad's. And I would mow the neighbors' yards for a couple bucks. That I would literally use to spend on penny candy and shit. Yeah, the 90s was a fun time. We still had penny candy and... yeah, anyway. I sound like my grandfather here. Sure to draw out the bolt holes. So there's the basic shape of our gasket. Isn't it pretty? Now I actually have a punch that I can use to punch these holes out with, so we'll do that later. I'm also going to probably use the punch to cut out the rest of this. But let's just see what we can get with our X-Acto knife. I don't have any fresh X-Acto blades. This one looks plenty sharp, so I'm going to use this to cut out the more complicated shapes. So back to my story. So what I was doing is I was mowing the yards. Anyway, all of a sudden the mower died. And it had no compression. I knew enough about engines back then to know that there was no compression. And then I noticed that it was basically spewing compression out the side of the, or the seam between basically the head gasket blew. Simple. So the head gasket was bad. And I took the head off. And I'm like, and I noticed I could still see the printing on that head gasket. It said Breakfast of Champions. Now, I didn't realize that Kellogg was in the head gasket business. Little did I know. So I said, Dad, this thing has part of a Wheaties box in place of where the head gasket should be. And he says, well, son, that's because that's what I used. Yes, what he would do. And he did this for he told me he'd been doing this for a while for lawnmowers because he didn't want to spend the money on the head gaskets whenever he needed to replace one. So what he would do is he would, whatever cereal box was empty that week, he would cut out the head gasket from a cereal box and he would laminate it with tinfoil. And you know something? It actually worked for a number of years. I would say that head gasket lasted about probably 3 years like that. Maybe longer. Because we had that mower for quite a while before he had done that. But we're not going to do that with this engine. We're going to get a real Briggs head gasket for it. I can still get one, and that's exactly what I'm going to do. But I have used cardboard as gasket material before, and it has worked in certain applications, but I'm not going to do that here. Okay. Here's our new gasket. Oh, I didn't cut out this part here. Anyway. I just thought that was funny. Breakfast of Champions. Apparently, head gasket of Champions, too. So how close are we to the original? Well, thickness-wise, I think we're pretty close. You know, come to think of it, this material isn't that much thinner. And when you factor in 80-odd years of wear and tear, we're probably doing pretty good. But the shape is pretty much exact. It should do the trick. See? So now we're going to get our punches and we're going to punch these holes out. I think we have a winner. One replacement gasket coming up. Now, do those holes line up with the original? They should. Let's take a look. I think that'll work. Okay, we'll put that in the good pile. Alright, how's our carburetor part stuff looking? Alright, let's see. Well, it's just starting to eat away at the grime. So we're going to have to put it in another, for another session. Yeah, I mean, it's going to take a few sessions. This is a very crappy tank. It doesn't do a very good job, so we have to compensate for that by, you know, running it, so to speak. By the way, these are antique punches. These were originally used in the Manchester, New Hampshire shoe industry. That's where these came from. These were leather punches that were acquired by my girlfriend's great uncle. He actually had worked in the pattern business. They were making like the wooden shoe patterns. In fact, it was his shop that this came from, and the spindle sander. That's where they were originally used. But these punches are kind of like a piece of local history. These are real shoemaking tools that were used. Some of them are damaged. I've got one that's broken, but I got two that are broken. And I got another rack of these things. One of these days I'll kind of figure out what's what and just kind of sort them out, but some of them are broken, but I have used these. They're remarkably handy to have. No idea who made them. Dirty as hell, but kind of nice to have when you're making gaskets and you need to punch a precise hole, or you're working with leather or vinyl. They're very nice to have. Here's a steel wool pad that we're going to use to clean the needle valves and the carburetor body once it's cleaned. We'll use this to kind of polish it up a little bit. But we're just going to spin it, polish it. Now the shellac on this cork is pretty much, it's not watertight anymore, or fuel tight as the case may be. I'm looking at this needle and it does have a slight groove worn into it. It should be replaced. Unfortunately, I don't believe I'm going to be able to find another. So we're just going to have to live with what we have, unfortunately. I mean, that's just, sometimes that's how it is. And yeah, there's a little pin, it's a nail, stuffed into the cork. I imagine that was used for ballast. It should still float though. Looking at how they put it together, this is so crude compared to today's technology, or even, again, technology from the next generation of engines that came after this. But this needle valve is placed into the cork. It's actually soldered. So they must have had a jig or a rig or something that to place this in just right, because the collar stops are soldered in place on top and bottom. So if you had to adjust the position of the cork, you had to desolder it and move it up or down that way. On a modern or newer carburetor, you would just bend a metal tab on the float. This is very primitive stuff, but I think it'll work. And again, modern day ethanol fuels. I know this engine had never run on ethanol before. There's no way, because this coating would have been gone. That's probably what's going to happen. This is going to dissolve in the ethanol fuel. Shellac can be wiped. So if you have any shellac, as an example, if you have any furniture that's shellacked as a clear coat finish, rubbing alcohol will destroy the coating. It'll wipe it right off. I know firsthand, because when I restored my 1847 clock, I used shellac because it was period correct. But when I screwed up, all I had to do was wipe it off with alcohol, and it just left it clean wood underneath, like it never happened. So ethanol, I believe, will dissolve it as well. We'll see what happens. Reset this for another couple minutes. Check out this bowl. Well, it's looking better. It's definitely not where it needs to be. I'm afraid that this buildup on the inside is actually from the casting. It's either from the casting itself, or it could be corrosion. Combination of both. There's definitely some sludge building up at the bottom here, so we need to kind of rinse that out. Well, the ports aren't blocked, I don't think. Well, not anymore. Those are choke. This is looking all right. A lot of tool marks from all the years of repairs and whatnot. A lot of stuff that should not be in there. Well, it looks like it's cracked on the inside, but that's how it was molded. Amazing. Take a look at the main body yet. It really isn't that dirty, to be honest with you. I think this carburetor, if I put it back together right now, I think it'll work. But since we got all the stuff set up, we're just going to let it fry for a little while. A while longer. Catch you on the flip side. Okay, by now anything that this tank is going to remove has been removed. So we're going to take our stuff out, put it out on this rag here. These parts really are so hot I cannot touch them. So I'm going to have to be very careful how I do this. I'm going to kind of clean some stuff up with the steel wool. There are some parts I can't get out with a magnet because they're not steel. Not everything is ferrous steel. So that's all I'm gonna get. I got it looks like a brass screw. And how quickly that shit evaporated. Not bad. I think once we get our steel wool to it, and we just start kind of buffing and polishing here, you know, this carburetor will look as good as it feels. I mean, work as good as it looks, or look as good as it works. I don't know. Anyway, it'll be good. All good and plenty. Charlie says, I love my good and plenty. It's good and plenty. So everybody knows that kids love licorice flavored candy. That's what kids crave. good and bloody. It's got what kids crave. Anyway, so there's our carby body. Let's do our choky moke. It's kind of rough. What this is doing, it is kind of smoothing out the surface a little bit. And, you know, making it prettier. Ooh, this is brass. I didn't know that was brass. Did you know that was brass? Look at that. It shines like the sun. Clean, clean, clean. Clean it up. Somebody took a pair of nunchucks or some shit. Really did a number on that piece there. I can't understand what they were doing. I'm still on a lookout, by the way, for an intake tube for, or a, yeah, an intake tube for this guy. Yeah. Does anybody have one? Please drop a comment. I need an air filter and the filter pipe. That's what I need. Anybody's got one? Don't be shy. I'm this far into it. I really could use that. So there's what looks like iron oxide. This is made of, this is not steel or cast iron. This is aluminum, just like everything else, or an alloy of aluminum. And noticing that it really does look like there's rust. You know, that could actually, I'm wondering if that could be some lead buildup from the fuel. This was made and operated during the leaded fuel craze. And I'm wondering if, I don't know what this screw is for. It caps off a port. And sometimes they'll put a, they'll use these as, well, I'm thinking that they use the screw as a Welch plug. So like a Welch plug on a carburetor body is often part of, it's just a side effect of the machining process. So if they need to drill a precision hole like here, or no, they need to drill a hole here for a port, and so let's pretend you need to have a port that goes from here to here. How do you do it? You run a drill bit this way, all the way here, and then you run a drill bit this way. But sometimes they'll run the drill bit all the way through, and they don't need the other side for whatever reason. So they'll cap it off with a Welch plug. In this case, they maybe could have possibly used screws. But I'm telling you, there's something at the bottom of this bowl, and I don't know what it is. Well, anyway. Alright, let's get this intake tube cleaned up. This has already gone through the evaporust process, which took away all the surface rust, and it had plenty of it. So we'll clean that off. And can't believe it. We're almost ready to put it back together again. Can you believe that? I'm going to check the parts diagram to see if there is a seal that goes here. I don't think there is. It looks like it's supposed to be friction fit and then screwed down. That flies in the face of everything that we know today. But if you look at how it's designed, the fuel is never supposed to reach this level anyway. Clever. So it kind of makes sense. Do I like it? No. I don't like it at all. But in the 1930s, fuel was practically free. So, you know, if it leaked out, who cares? Pump more out of the ground. Who's going to care, right? No, seriously though, I'm finding that a lot of see, they didn't have the technology we have now, and the materials to make seals that were fuel resistant out of rubber. I don't think they were at that point where they knew how to make a rubber seal that was fuel resistant. So they just figured, what the hell? We'll just figure out a way around it. Again, some of these parts are unobtainium now, like this needle valve. So if this was bad, I don't have one to put back in there. There's nothing on the market today that will work. I can't even find new old stock anything for this guy. Look at this. The needle valve is soldered to this fitting, this threaded fitting. Nowadays, they could make this out of one piece. Back then, not so much. Maybe they could, but the engineering costs were too high. And they were just about to go to war, so, you know, of course they didn't know it at the time. This is pre-World War II, baby. Alright. So, I cleaned up this as much as I'm going to do. Let's leave it with a nice little patina for a good time. And I think that'll do. Now, I didn't think to, I'm such an idiot, to count how many turns in or out it was supposed to start out at, but, well, we'll figure that out. The port doesn't appear to be blocked, although it just might be. I'm going to run this over to my air compressor and just check it out, make sure that there's nothing blocked. Now, I've worked on suction carburetors, the Pulsa Prime, Pulsa Jet carburetors. I've worked on CV carburetors. I've worked on a standard, you know, 2-barrel carburetors. I don't quite understand the theory of functionality behind this unit. Okay, so I blew out the bowl and everything. There was definitely some sediment at the bottom here. And it just hit me. Hold on a second. Just now, just as I'm speaking, it just occurred to me. No, it's not. It's not okay, so it's not steel. Anyway. So, here's where I'm going with this. So, I can clean this up with a grinding wheel. I might just do that. Anyway, we'll put it in the body first. That way there's something to hold on to. Here's where I'm going. So, this carburetor makes no sense to me. Okay? Here's why. Where's the body? Oh, I must have left it in the garage. Okay, so how's that look? You like that? I like that. So, here's how these two parts fit together, and their precision is, well, more like Soviet era economy car level of precision. Well, anywho, even with a gasket, I don't think that's going to seal. I'm going to have to plane these somehow. Never ends, huh? So you've got your hole. This is the hole that the fuel enters the Venturi through. And it looks like there's 3 ports here. 1, 2, 3. Fuel enters. It has to enter where, I don't know. So either there's a blocked port somewhere. It enters through the bottom. But that port bores out to here. Oh, wait. Nope, there's a tiny opening for fuel to go from there into this little area here. None of this makes any sense at all. I'm sure it's very simple. I just can't make heads or tails of it all. I checked, none of the ports are blocked. I checked with my air hose. Everything seems to be flowing free. Okay. I see. Alright, so the needle valve, yeah, there's some schmutz down in there. I'm gonna have to clean it out with a wire whisk, they make little carburetor brushes. I'm gonna need to clean that out because it does not look clean enough. So alright, so your needle valve goes all the way down into here where it blocks that central port where fuel enters the area. Okay, I think that's where it bottoms out. My fear is I'm going to deform the needle by putting it in too far. Again, it has the precision of, well, like nothing I've ever seen before. Now, I don't have a flat, oh, you know what I have that could be a good surface for planing? I have this steel table here on the spindle sander, so I can use that. I can use that as my planing surface, and I can do some progressive sanding. Here's some 180 grit. We'll start with that. And we can sand this. Oh, not this. We can sand our carburetor body good and smooth, and then kind of use a, yeah. See, look at that. It's just got some high edges. It's getting better. This is as close to a precision flat, a true surface that I have. You can see where it's not touching. So that it's got high spots around here, but it's low here. And something tells me it was made this way, and it's been this way its whole life. See, now we're starting to get to the meat of the potatoes. Let's try this side. So this one, the high side is the edge. Yeah, the edges are high. It's not supposed to be like that. We're actually making it better than it was when it was built by doing this. Let's see if they fit together a little nicer now. Actually, yes, they do. So I'll just keep up with this and get back to you. I want to point something out. Laziness, lack of attention to detail, and just plain, you know, poor quality was not invented in 99 or whatever generation you want to pin this problem on. This was built 85 years ago, and these surfaces should have been machined from the factory because now they fit together, whereas before they didn't. In fact, I could almost put this together without a gasket right now and it would still work. But before, it was kind of a disaster. So anyway, where were we? So I need to clean this up. No, I don't. No, I don't. No, I don't. Okay, so this is going to go into here. Oh, I wanted to make. No, I did double check to make sure these ports were cleaned. But I want to stick a piece of wire or something to it. What do I have? Anything of note? Thing. I think I have a little bit of Why don't we do this? Why don't we just flush it out with WD-40? I'm going to stick the hose down. Okay. Yeah. It's not full of crap, so we're going to just put our needle valve in. Let me just lubricate the... Don't you hate these new WD-40 cans? I hate them with a passion. Why did WD-40 mess up a good thing? I think that's all the way in. So we're gonna 1, 2, no. See, if I go any farther than that, it doesn't hit the detents anymore. So maybe it's like 1 complete turn. I don't know. We'll have to play with this in post. It's a joke. Post-production joke. Anyway. Okay. There's our carb. There's our float body. Why don't we get these surfaces wet so that gasket can slip and slide away. Put these two guys together and make magic. Looks like it was going to be either these two bolts. Yeah, it's going to be these two bolts here. There we are. The unfortunate thing is I won't be able to test my handiwork until, well, it'll be a while. it'll be a good while before we can test any of this out to see how good I did. But we've definitely improved the seal between the float chamber and the carburetor body. I don't know what they were. There was no attention to detail there, which is just kind of gut-wrenching. Like what on earth were they thinking? But anyway, it was good and tight. Okay, so there should be no leaks there. No vacuum leaks. Did we get this on upside down? Speaking of attention to detail, we assembled it. Did we really? By George, I think we did. Idiot. All right, let's assemble it right this time. I think I got it upside down. Yeah. Getting late. Camera battery's about to die too. Oh, that sucks. Maybe I just wanted to see if it went together that way. See what would happen. Or maybe I got it right. Just take another look at it. Oh man. So the gasket goes on like that. Now I don't like how I'm gonna take my punch and I'm gonna clean up this bottom area just a wee bit. Which punch did I use? This one? Or no, I used the bigger one. I'm gonna use this guy. I'm just gonna round off this area just a wee bit, and yeah, I just don't like the way that went together. There. See, what was happening was it was kind of blocking that hole just a little bit, just a wee bit, a little bit of a hindrance. I probably should do a little more too. Where's my punch? I'm going to go downwards a little more. There. Okay. Give it a little more flow. There we go. See, I didn't want that little diamond shape right there. I didn't want that blocked at all. So that's what we're going to do. Okay. Now, how does this go together again? Like this. With the... Yeah, that looks about right. Yeah. Yeah, because the choke is on the bottom. That's how it goes together, just like that. Okay. It's going to be fun getting this thing running. This engine is going to be tough because it's going to require a lot of kind of fine tuning with the ignition system and the carburetor, getting it all just dialed in just right, so that everything works together correctly. It's going to be interesting to see how that all plays out. There's our choke. Chocus Magocus. Oh, it goes on like this. I probably should have put a little punch mark to show, but I can always adjust it later if I need to. But a little punch mark to show where it goes in relation to. So this gets mounted to the block like that, and then the choke blocks here. The choke is kind of like off to the side a little bit. Well, we can always adjust it later if we need to. We're probably going to have to. Once I find my intake pipe, this block or this stopper here for the float drain, it is tapered. I just noticed it has a tapered thread to it, which is kind of interesting. We still don't know what this is for. You know, it just occurred to me, think about this. It's almost like a deliberate vacuum leak. You know? It doesn't make any sense as to why that is there. I don't understand. I'm going to have to find the manual for this engine to really understand what that's all about. But here's our float. Float goes in needle side up. And the float chamber goes on top. The fuel hose is coming in. I'm trying to think here. Either it goes this way or it goes the other way. No idea. I'm thinking, all right, the carburetor's coming. Oh, it goes the other way. Yeah, that makes more sense. Again, there's no seal on that float chamber. At least none that I can see. What's left? I've got this one split washer. I think these two should have had split washers on them, but I only have one. So I'm not going to worry about it too much. Yeah, that's it. Simple. Such a simple design. And these are fit, again, like I said, these are fitted much in the same way that your musical instrument foot joints are put together. And they wear out. Eventually, you know, you're going to have to put some solder or some kind of sealer into here. But we'll worry about that when we're ready to start the engine. Put it back together for real. But here's our carburetor, all ready to go. It should work. What an interesting artifact from history. I've never seen anything like it before. And this is my first foray. Actually, this is actually no, I take that back. So the International Harvester LA engine is even simpler than this. The LA engine carburetor is I don't even know how you can call it a carburetor at all. It only has one adjustment. It's for the fuel flow, and it doesn't have a float. It's basically just, think of it as this pipe right here with a tube coming out of the tank and a needle valve to control the rate of fuel flow into this chamber. That's it. The throttle plate isn't even on the carburetor body. It's part of the block. It's in the block. It's in the port. The carburetor is nothing more than a chamber and a venturi, and that's it. Just a little venturi, a little spot for the fuel to flow in, and a little needle valve to control it. That's all you get. And that engine was about the same age as this one. I'm noticing that the throttle is interfering with the with my needle valve. I don't know why that would be. Kind of makes no sense. Screw this in by hand until it stops. Just open it gradually. This is all soldered together. But why? Why is that interfering? Well, this does look a little bent. So I'm going to probably give it a little bend back. That could cause a problem. Yeah, it's got a little bend to it. So let's try to straighten it out. There. So this right here, this is a crimp fitting for a, I believe this is the crimp fitting for the throttle cable that I don't have. Oh, wait. It could be my idle control stop. Let me check the parts manual and see if anything goes here. I think there's supposed to be a screw in here to control idle speed. Or that could be part of the governor. Well, I guess we'll find out in our next video, maybe. Have a great day. Thank you for watching, and I hope you learned something, because I know I have. So I can confirm that there is no gasket between here and here. There's one gasket for the carburetor body to the 296 assembly. We still don't know what this is. 63157. Let's see what that is. So this manual, by the way, is available for free while supplies last on Briggs and Stratton's website. By the way, this is what I need. I need this assembly, if anybody's got one. 61664. And that should be for the 5-digit serial number models. But I might even accept one of these if I get my hands on it. I think this is an optional air filter that mounts directly to the carburetor Well, maybe not. Or maybe it does. I believe it mounts directly to the choke horn, 29288, or you get this. Either way, I need an air filter. Really bad. Really bad. So what was that part number? It was, let's see. It was 63157. Let's see if we can find it in the parts list. This is not a full 62 65 634 62 screw carburetor air bleed. Well, all right then. And this is where it would come in handy if we had an engine type number, because some of these parts are for specific engine type numbers, which we don't know what ours is. We don't know the serial number. We know the serial number range, and that's all we know. It's a 5-digit serial number, and that's all I know. Don't know no more. So that's where we're at. So I need an air cleaner for this stupid thing. 69423. 69. Yeah. Another thing. Let's take a look at the engine seal part explosion. So there is no seal. There is merely a retainer, and that retainer is supposed to prevent oil from splashing out. That's all it does. And I think you're supposed to fit it like with a special tool, and it's supposed to be fitted or bent into position so that it seals the crank. And there's not much I can do about that. But there are no seals for the crank, which is mind-blowing. So I got to order, as of right now, I got to order a head gasket, and I need a valve push rod cover gasket. 69423 is the entire assembly. I need that. I think that's what I think that'll just bolt right to the carburetor. So now I'll see what I can get. It is $210 and out of stock, but it exists. Damn.